in this first example here, we're just going to quickly take a look at what is the slope of each of those lines. Now, often, if we were in class, we would be doing this as a class, and we'd be counting them all out. I'm going to go through a little bit quicker so that it fits into this video here. But our slope is m, and is always rise over run. So you'll notice that this roof here has a roof line according to this. If we go from this point to that point, it has some run and it has some rise. And to quickly count this out here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is 13 as well. Yeah, sorry, I counted one too many. So the run is 13 and the rise is 13. So we have a rise of 13 and a run of 13. That's how we would write out our slope. So our slope is 13 over 13. Now, as we're going to write it out as a fraction, and that fraction, okay, can be simplified. 13 over 13 can be simplified to 1. We can also change it to a decimal by dividing. It's going to give us the exact same one. But whenever we have a fraction, we always want to simplify it to something a little bit easier or the most basic, and that's important to do in anything that we have. Roof B, our slope again, rise over run. And it doesn't matter which one you count first, but I'm going to count rise first here. 1, 2, 3, 4, 5, 6, 7. So we have a rise of 7 and a run of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 7 over 12 would be our slope. Now, to simplify this, we got to see, is there a number that can divide evenly into both 7 and 12? There is not. So in other words, it is as simple as we can go. We could also change it to a decimal, which we don't necessarily like to do. We just divide 7 divided by 12, and 0.58, and then 3 repeated, so we're just going to leave it at 0.58, as that is rounded to 2 decimal places. Sometimes fractions can be a bit challenging to see which one's bigger and smaller, so that's where it's nice to have a decimal. So if you want to do a decimal just to kind of represent which one is bigger and smaller, you can definitely do that. The last one here, rise over run. So I'm going to do run first here. It's 1, 2, 3, 4, 5, 6, 7, 8. So 8 is on the bottom. And our rise is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14. We can simplify this to 7 over 4. And when we divide, 7 divided by 4 is 1.75. So our decimal will be 1.75. This is the correct answer. This is to represent a little bit nicer sometimes as to what we have there. Okay. Now, if we look at these 3 examples here that we have, which roof is the steepest? Which one has the steepest? Well, that is definitely roof C. This is our steepest, and this is our most shallow. Okay. You can look at the numbers here. The steepest roof has the biggest slope, 1.75. The shallowest roof, or the least steep roof, has the lowest slope at 0.58. And this one is 1, it's right in between. You can see that by looking. That's what represents our really steep or really shallow slopes. It's all about the number. And the higher the number, the more steep the slope. The lower the number, the more shallow the slope. And that's going to be kind of represented based on our fraction as well of rise over run. Now, the slope of a line can be found between any 2 points that are on the line. Okay, these ones that we did here, we took the end points, but sometimes we won't have end points. We'll just have a whole bunch of points and a long line, and we can pick any 2 points which are going to help that. All sections of a line are going to have the identical slope. Okay, so it doesn't matter if we take this section of the line, that has a slope of 7 over 12. This section of the line has a slope of 7 over 12, okay, because it's all one straight line. And so it's important to remember that all points have the same, all sections of the line have the same slope if it's one straight line. If the line has been broken up or if it's different, then it'll change. But as long as we have the same line, it'll have the same slope.